How much time do we have?
I think we have it's 45 minutes, if I'm not mistaken.
Oh, okay, great. Then we have ample time. Thank you so much, Simone. And it was wonderful to be at the rowdy dinner. Luckily, my voice is holding up for now. Thank you. Let's see if screen share works. Everybody, please cheer for me. Let's see if I can find success. Maybe. Okay. Wait, what? To avoid it. Okay, fine. Google Translate. Okay. Is something being shared?
Yeah, we can see the mirror board.
Okay, great. As Simone was just discussing the speed of the company, this part might be kind of exciting, and maybe there's pieces of it that can be directly used. I'd like to talk about how fast the company actually is. Here's a first look at how TeslaSpeed actually works. That's a European Union government term now. In the EU Parliament, calling fast execution TeslaSpeed is a coined term in the EU Parliament after seeing how fast Giga Brandenburg, that factory, was built. The purpose of Agile across the whole company, the hardware, the software, the business, is more innovation. When I was working in Tesla, I started what was called Agile in Tesla. Please, let's use the term Agile broadly here. I don't mean like stand-up meetings or anything like that. I'm simply talking about pace of execution. As Simone was saying, it's successful. Here's United States light vehicle sales year to date, Tesla versus Ford. Now this is percentile. Tesla still has only sold 3.5 million cars total, vehicles total. But by percent, we can see everyone else is shrinking and Tesla is exploding. When this data was first shared, the caption was, "What is the market signaling?" I thought that was genius. Like it's very clear there's a disruption going on. And this is exactly the data Simon was referring to. Tesla is the most valuable car company in the world now. Elon Musk prioritizes speed of innovation over all else. The market seems to love this. How does it work? Now, this data is from a year ago, almost exactly a year ago. Tesla is down in value right now relative to this snapshot. That said, almost all of these companies are also down in value. So the ratio is actually similar again today. Tesla is the fourth largest, or when this snapshot was taken, the fourth largest company by market cap on the US stock market, and larger than the next 10 incumbent companies added together. One reason it works, this is a video clip that won't play very well through Google Meets, so I'll say what happens here. This video shows R&D, research and development, on the production line, which is how it's always done. There's not a separate R&D facility. R&D is done on the cars, on the batteries, on the software, on the production line for fast feedback. So as soon as an R&D piece is successful, it passes tests, it's released into production even in volume of 1. Now this is a practice taken from software. Elon Musk has a software background from PayPal and Zip2 before that, Silicon Valley fast software company. The idea is you have a group of people checking each other's work, developing, in this case hardware, but also software, on production. And you have automated tests running continuously. There's not a test phase, they just continuously run. That works if you have fast rollback, if you can roll back whatever you just made in 5 seconds or less. Tesla does that in hardware, and it's completely disrupting the automotive industry. So production design never stops, and product design never stops. There is no design phase. Design is constant and continually improves product and process design as rapidly as possible. When you're hired into the company, every single position, part of its job description is Part of your role is to eliminate processes. Part of your role is to eliminate parts. Part of your role is to eliminate lines of code. The goal is the cars get fewer parts and the lines of code actually shrinks. The value should increase, but the goal is a simpler product base that allows the company to keep speeding up and speeding up and speeding up. Now, simple is hard. So if you have a new idea, a new thing you want to add into software or into hardware, you do it in a group of usually 4 or 5 people. So people are thinking, how can we simplify this? How do we accomplish it at all? How do we test this? How do we make this legal? How do we make this safe as you're developing? Because you're putting that new design, software, hardware into production as fast as, well, daily, right? There's not like you submit it to a test cycle. You have automated tests that are running real time to help you, but as soon as you think it passes, you deploy, and that's multiple times a day. That takes a huge amount of confidence, right? So you have this whole team helping you build confidence. All right, I checked this. Okay, I was messaging our legal expert while you were doing that. Okay, I see the design pattern that we're using is actually antiquated. It no longer applies. Let's rewrite it now that we have an idea using this new design pattern. It'll have fewer lines. And that's happening in real time. What that means is production is not an assembly line. Some people even think software development is an assembly line where you have like your design and architecture group, and then you have your patterns and practices group, and then it's handed to development groups for back end and separate development groups for front end. Some people think it's a lot like an assembly line. That's even software. Well, Tesla doesn't do software like an assembly line. They don't even do hardware like an assembly line. What they do is you have these groups of typically 4 or 5 people that are checking each other's work. These groups, I'll call them mobs. These mobs of 4 or 5 people. They get code in, or they get part in, so physical parts or 3D designs or software, they pull it in like a pull request, right? They get it and they mob on it until they've made some meaningful improvement. That could be it's just as capable as it was, but it's simpler now. Fewer lines of code, fewer CAD lines, fewer parts, less bends, less processes. So either they've not reduced value and it's gotten simpler, and then they release that immediately, replacing the old version, or they've added value and maybe it's gotten more complicated for now, but ideally they've added value and it's gotten simpler. And they take pieces and release them, take pieces and release them. They take any piece they think they can solve in that group of 3, 4, 5 people, that mob. And people change mobs periodically based on what they're most interested in or where they think they could add the most value. And people recruit each other through iMessage. Our mob is doing this kind of thing right now. I know you're really good at it. Can you stop by even for a few minutes and join and help us work on it for even a few minutes or sometimes for a few weeks? But they'll recruit each other and they come back and forth, which is part of this self-management. When you join the company, you get a list of rules. It's 4 pages long. As long as you don't break those rules, you can self-manage. So it's not that you can do anything. You have 4 pages of rules. Well, 3.5 pages of rules. And you have to hold yourself accountable to those. If you didn't, it would be a problem. People would hold each other accountable. They'd say, you're not following the rules. This is a problem. And they'd talk to you about it. And if you were not following the rules intentionally and you had no interest in improving, you'd be asked to leave the company, right? Because you're not holding up to the rules. But if you accidentally miss something, people will help you. But as long as everyone is trying to abide by those rules, you can largely self-manage because those rules give you guide rails that say you're being useful to the company, hopefully in a very effective and efficient way. So there's actually very little management. You have to self-manage because you have this rule set. And there's apps and software and rules that help you. This area is not being very efficient. An app will actually tell you that. We're not getting much output for the money we're spending in this area. So the people in that area say, we should either shut down this area and go somewhere else, or we should try to improve this area, right? So there's tools that help you self-manage. And there are managers. It's just they don't do things you might expect. Like they don't do performance reviews or anything. Here are pictures of what is now Giga Texas. The picture on the left was taken the day the land was bought. The day the land was bought, the land was cleared and leveled the same day. Now, interestingly, in the US, when someone buys land, when a company or a group or an individual buys land, it's recorded publicly who bought it. And for tax reasons, how much they paid. You know, that's all public in the United States. This land is in the United States. This is in Texas. It wasn't bought by Tesla. It wasn't bought by Elon Musk. It was bought by an employee. Really, this huge piece of land. An employee thought, well, we really need more space. And this land is at a great price and it logistically makes sense. Okay, we'll buy it. And they just bought it. You can see it. It's an employee. They just bought the land. And it's not like they asked Elon, can I buy this land? Right? Their whole mob of 3, 4, 5 people, like all decisions in Tesla, had each other's back and said, yeah, this looks like it actually makes sense. And they're iMessaging other people, not for permission, but to check their assumptions. Yeah, this is actually an awesome opportunity. Let's do it immediately. And when you're working in these mobs, these groups, your speed of execution is extremely high, because you can go from, I think this is a good idea, to I have high confidence this is a good idea in minutes. And you can execute even really big deals this way because you have this supporting mob, cross-functional, cross-skills, right? So they bought this land, and as they're booking the land, as they're arranging the purchase, they're also renting equipment, huge earth-moving equipment, to clear and level the land, and hiring any contractor they can that will do it. Now, they don't only, you can't just wait on contractors if you want to go this fast, so that it's parallel execution. Tesla employees are also getting on rented equipment to drive it themselves and learning how to drive it on YouTube. And they're hiring contractors that know this stuff to also be driving. So they cleared and leveled the land the same day it was bought. 90 days later, you can see the factory modules are being connected. We call this the factory fabric, this repeating network of modules. Now, these modules are actually each different, not by some master design, because people figure out better ways as they're building, how to use less material, how to use a less expensive material that will last longer, how to better manage electricity inside these facilities. They're changing as they go. Here, they're being kitted. I know it's getting pixelated here, but these are the kits of each module, and they're being designed as they're built. So as they're being built, they're reducing the number of bolts, or actually strengthening different areas, or materials run out. The supply chain crunch is very real. So we can't get this shape of metal anymore. We can get this other shape. Let's compensate. Let's re-engineer. That's happening here. And there's not just one design at a time. There's multiple layouts of these that are each a little different. They have different mobs working on them, redesigning them. So they're not all the same, even at the same time. They change over time, and more than one version changes over time. The important part is they can still connect. The important part is that either the way they connect, the interface, it stayed the same, or they've produced an adapter, like physical plates that connect these parts and connect the heating, ventilation, and cooling between the two, connect electricity, connect water treatment between the two. As long as they can connect, the designs can change in parallel, and they don't have to wait on any design review, right? They test, connect, can it connect? And if it does and it's robust and it passes test, then it's done. Now, some of these modules already have solar panels on top. They all get solar eventually, but some of them already have solar. And some of them already have their own wastewater treatment at some level, to return it to rainwater quality. What that means is they can already be operating. If we zoom in even more, we can see the factory pieces, which are not done. They're already designing and producing car parts. This is 90 days after the land was bought. This is TeslaSpeed. This is unreal. Like, some of you have seen train stations in parts of China that are built in a night, right? So this isn't the only company doing it, but this is happening outside of China with all the rules and regulations. Giga Bradenburg in the EU is the fastest modern factory ever built in the EU by a factor of more than 10. This TeslaSpeed thing is really, really quick. Here's an older version of those same factory modules. These aren't nearly as tall. They're not 4 levels tall like in Texas. This is in Giga, Nevada. This is the first Giga factory. But what I like about this photo, even though it's an older version of the modules, is you can see the tents. So these tents are engineering. In these tents are people on laptops designing, in this case, batteries and the machinery that will make batteries. And they're making them. They're rolling batteries, they're mixing batches of chemicals, they're testing them. They're actually doing the work with real machines and laptops in these tents. And as they're doing that work, construction of the next factory module happens over them. And a lot of companies have a separate construction group or an external construction contractor, and then they have the people that write the software or develop the product. In Tesla, they mix. So these people in the tent making batteries will rotate with other Tesla employees and contractors who are constructing the module. And they'll rotate back and forth, they'll cross-skill each other. They do this, one, because it's fun. Two, because it's healthy, actually, to not just do the same type of work all the time. And three, because it makes a better product. The factory fabric, as it's built over this piece, matches the type of work that's being done there very well, because they're exchanging roles, this radical cross-functionality. I spent most of my time in Fremont, California, and we had existing buildings. We didn't start with with land that we could level. Like in Nevada and in Texas, they cleared the land, they leveled the land. In Fremont, California, it's not cost effective and possibly not even allowed to clear the land. You have these existing buildings. So what we did is build pylons, big, strong poles, big, strong standing columns inside through the current building, and then built the same factory modules, the same factory fabric on top. It's much more expensive to build on top, but you don't have a choice if you don't get to clear the land. So that's what we did. When you clear the land, we called this modular XY construction for the XY axes. When we had to build up, we called it modular Z construction. Now, modular XY does also build up, but you're building up on top of a cleared base. You don't have to create these supporting structures through existing buildings. Let's look at SpaceX, another Musk company. Here are the first 8 sprints at SpaceX. Please note, each sprint, you don't have to use the word sprint. You could say release or iteration. In a Musk company, it's the same word. I know some companies call a sprint 2 weeks, whether you get anything done or tested. That's not what I'm talking about. In this case, when I'm saying sprint, I mean a product release, which is what sprint originally meant anyway. So, I mean, that is the original meaning of sprint. You sprint through design, planning, and test to release. And that's one sprint. And you sprint again to another release. In any case, these are the first 8 releases. Sprints, iterations, releases from SpaceX. Note, each sprint is a product launch. The first 4 sprints took 2 years each. I mean, that's pretty fast for rockets, but Musk wanted to go a lot faster. Then 1 year, they shortened to 1 year each. Each sprint added automation to speed up design, feedback, testing, installation, certification, etc. So there's automation to help with the certification process. There's automation to help with the installation process. You, in ScalaPay, already have a lot of automated testing, and you have some automated feedback and analytics. Automating part of the certification process is also helpful. It compounds the overall speed to done and in the field, right? This is hardware DevOps, right? Like the DevOps you already have. This is applying DevOps to hardware, automated test and deployment. A practice that Musk uses, all the Tesla and SpaceX employees use, is they co-locate. They have sitting together, a mixed skills group. In this case, design, build, test, and launch people are together, and they mix. They actually try to learn some of each other's skills in these mobs to help each other. Now SpaceX is on 2-day sprints. not an entire rocket, but an entire rocket engine can be designed, built, test fired, and installed on the rocket in 2 days. A commercial rocket launch occurs with new hardware and new software every 5 days now. It's even faster than when I wrote this piece of the presentation material. So here are Raptor engines. Each one has a different set of pipes, different software, different wiring, different alloys, different types of metals, different diameters and bell shapes to try to be faster, cheaper, lighter, more durable, more effective. I don't know how many people here know these nozzles of the rocket engines, they have material inside. It's an ablative material. By that means it breaks off in little pieces as the rocket fires. That takes heat with it. That's why the rockets don't melt when they're shooting out at such extraordinary power. I mean, these are the most powerful thing per weight on planet Earth. Like they are. There's not a thing that's smaller and lighter that produces as much power sustainably. So they're incredibly hot. And the reason they don't melt is little pieces of material inside the cones break off as it fires, taking huge amounts of heat with it. And that material is different on every single engine. It's applied differently. It's applied in different shapes, different lattice shapes. It's applied by different types of machines, all experiments to make the rockets last even longer. And these are the most efficient rockets on planet Earth right now. SpaceX has far and away the most advanced rocket technology. And it's not because they designed it great up front. It's because they've made so many different designs by now. If you're in a Musk company, pace of innovation is the only thing that matters in the long run. Not financial efficiency, although they are now very financially efficient. Not optimum use of resources, making sure no one's waiting. Not that. It's pace of innovation. And everything is optimized for that. And as a result, they have many best in the world technologies. It starts with a tent building rockets. This is how SpaceX, Boca Chica, Texas began. This is the first structure. I'd say building, but it's not a building, it's a tent. This is the first thing. So you're just on open desert. And this is a dirt floor and a tent. And they're running it off a generator. They don't even have connection to power utilities yet. They're using plastic outhouses, rented outhouses. Engineers come into this tent with laptops. And those same engineers start drawing rockets. And they start ordering metal themselves. They don't have a separate procurement group. I mean, those same people get on the internet. Where can I buy metal? And call people and try to negotiate a price. And they'll iMessage other people. Am I doing this right? Am I getting a good price? And they'll run apps that help automate price search. Am I getting a good price? And they themselves will then order the metal. And then they'll talk to the driver to be like, no, we're down, we're further out, we don't have an address, we're further out in the desert. I can see you, I'm waving. I mean, it's the same people handling all of this. The metal arrives and they start trying to build it. They themselves start trying to weld it. And what they do is they post on the internet, we'd like welders, people with welding skill. And they hosted a contractor day that became a hiring day where they said, anyone, if you can drive here on this day at this time, we want you to test weld a bunch of stuff so we can evaluate your skill. And this is the same people who 3D drew the rockets. It's not like some human resources group. And hundreds of people, there's funny photos of in the desert, it looks like a traffic jam of hundreds of usually trucks in the desert, right? And they're lined up at this tent. And these people come out, and they have their own like welders and generators in the back of the truck, and they weld. And what they're welding is this. So your interview is actually welding part of the largest rocket on planet Earth. And if you're not great, you don't get the job. And then the next welder has to try to redo it, fix it, or make another one, right? So there's a huge discard pile. If you're looking at efficiency, this is a horrible way to manage your cash, you might think. The result is incredible speed. SpaceX makes an entire new Starship rocket every month. Every month. New software. the new physical rocket, new pipes, new cooling, new rocket engines, and they test fire it. They either static fire it, bolted to the planet Earth, or they actually send some of them up to a certain altitude and bring them back every month. They're actually a little faster than that now. They're on Starship 27 now. This is the first one. This is first Starship ever. And it starts with a tent in the desert. And a city building rockets organically evolves based on what is needed at the time. No one drew a plan of where the next tent would go. The people doing the work ran out of space and they ordered tent parts. Got tall enough that they worried a high wind event could knock the rocket down. They built windbreaks, these towers, to hold on and go over the stacked rockets, the rockets as they got taller. Again, there's no master plan for this, and there's no one to approve it. Just the people doing the work organically evolve the facility as they go. Every week, the facility expands to increase speed and quality of what is built there. The factory is the product and is treated to product design, user interface design. Artistic beauty and style is built in as the facility develops. The factory should be beautiful and easy to use. This increases every iteration. So there's not a master plan where we check for usability or check for beauty. Everyone tries to build in beauty and ease of use and ergonomics. So in these mobs, they're often iMessaging or using Signal to contact people with good design skill, good user experience skill. And those people are joining different mobs. So there's not like a UX mob, right? Those people are in other mobs doing work. Like UX isn't something you get done by itself. User experience is something that is shown in the pieces of the factory as they're built and in the products as they're built. So these people join other mobs. So a UX person might be welding as part of that mob, working on whatever's being made at the time. It's radical cross-skilling. And a sprint review is a release, right, as mentioned. Here are two Falcon 9 boosters. They launch, and in this picture right here, they're landing autonomously. It's automated. There's no human manually controlling this because we want speed and repeatability. Sprint reviews are automated for speed and repeatability. So we can do it again quickly if we want to. We can make a small adjustment, do it again, a small adjustment, do it again, and get a full feedback loop. In one sprint, these are the parallel executing work streams. Each has their own procurement, their own mechanical engineering, their own software engineering, etc. The purpose is to avoid waiting on central services. And the reason for that is for maximum speed. Notice Starship is on version 27 now. There's a new one every month. So the booster team, I mean, you could think about that like back end, right? There's the booster team, and they have a known stable interface to Starship, which you could think of like the front end team. And that interface changes all the time. But whoever changes the interface, they provide an adapter, physical and software adapter, so the other team doesn't have to change before they can test. They can continue working to the adapter. It doesn't disrupt the other team, even if you change the interface, as long as you also provide an adapter to backwards compatibility. And both of these teams consume from the barrel sections team. Every one of these barrel sections is different. New alloys, different embedded software, different embedded sensors, cooling lines, cabling. They're consumed like a supplier by Starship and Booster. Now the internal tanks are also common by Starship and Booster, and they're consumed also like an internally owned supplier. The tank dome header, tank dome footer, and the barrel sections group. The same, you could think of orbital launch mount like ops, like an operations team. As long as the interface is the same, ops changes all the time, every day. There is never, ever a request to hold back a release or an innovation. Like that would be, if pace of innovation is the only thing that matters, that'd be horrible to say. No, don't change that, right? No one says that in a Musk company. Change as fast as you can, but provide an interface so that the other teams aren't interrupted by your release. So we have these stable interfaces. In this case, it's called the orbital launch table. That's the same thing that attaches to the top of ops, orbital launch mount. They don't call it ops. I'm trying to make an analogy here. To booster, which you could think of like back end maybe, and to Starship, which you could think of like front end. So they can all release different versions multiple times a day. And this changes itself. So it gets adapters added regularly. Okay, I think we're at a good time to see if there's any comments or questions. We've gone through 1/12 of content that Simone and Ricardo went through. There's 12 pieces of what I think we could learn from a Musk company and what I called Agile at Tesla. And you've seen 1/12 of it. Yeah, let's see if there's any comments or questions. And already, thank you very much. Yes, Tommaso. Wow, the hand raise tool. Yes,
Yeah.
go ahead.
I mean, it's useful. Let's use it. Hello, thank you. I actually wanted to ask for confirmation. When you talked about the mobs, you said that it was cross-functional. Does that mean that the teams that actually build the mob itself have different sets of expertises and come from different teams?
So that you choose which mob you join, and you get recruited. Right, people will say, I think you'd help, can you come? And sometimes they can't, right, but they recruit each other. As a result, it's a complete mix. Yeah, people are from every group. In fact, I'm not sure I ever saw a mob that was only one type of skill. It'd be too risky because they're not getting cross-functional information. So yes, to answer your question, yeah, they're coming from all over. The mobs are very widely composed.
Thank you, Joe.
Yeah, thank you, Tommaso. Great point.
Guys, feel free to ask questions. Don't be shy.
Or comments. I mean, I'm willing to learn. I might be wrong. So you can say, actually, Joe, it's like this. Yeah. Paola,
Yeah.
Yes, go ahead.
Hi. I just ask a question. What about, I mean, they do only like one prototype. About the cost. The question is, what about the cost of making something that maybe doesn't work, but they do only one prototype? So, I mean, the cost is reduced, or they do, I don't know.
Yeah, if we looked at this from a burn rate perspective, how quickly the company is spending money, it's not what you'd, how can I say, it's extremely expensive because every single unit is essentially a prototype forever. So there's not a prototype and then production. It's make another one with anything you learned from the last one as fast as you can. That's primarily the governing thought process for the whole company. Make another one that's, I hope, better than the last one as fast as you can, period. And it doesn't mean someone's bought it. Like most rocket companies, they wait for someone to buy a rocket launch and then they make a rocket for that launch. So they end up making a rocket every few years and it's very expensive. SpaceX makes another rocket no matter who bought one. Well, because they don't sell rockets, they sell rides on rockets. You can think of SpaceX more like Uber. You buy space on a rocket and you don't know what rocket it's going to be because SpaceX is simply building rockets as fast as they can, even if they're never used to put a payload into space, right? So you'd think logistically the finances don't make sense. The result is SpaceX is far and away the most profitable aerospace company in the world because the rate of improvement, the pace of innovation is the only thing that matters, and it wins financially, even if it looks ludicrous in the beginning. So yeah, so there's not like one prototype and then production. It's never ending build as fast as they can, which has a huge capital expense. But it wins because the rate of innovation is higher than any other model we know so far.
Cool, thank you.
Thank you, Paola. People are
Joe,
getting
maybe worth. Antonio, you go.
Hi, Joe. I'm Antonio. Just a question: how can the teams don't step each other feet?
Yeah.
If they are so fast, so how can be possible? For example, you made an example. They build a windbreaker or something like that, but it could be that someone else built something in the exact place where that windbreaker needs to be put. So how can it be possible that people don't create problems to each other?
Well, sometimes they do. Sometimes they do. What makes it happen a little less is there's a lot of automation, so you can see what people are doing at a glance. There's these monitors just up above everybody's head, about every 3 meters in every building. They weren't in the tent I showed you because they weren't installed yet, but they are now. So they're just above your head. It's also on your phone. And what it does is it gives you this project view. It's called the Justice Board. This project view of basically what's going on right now. And it's a simplified, I'll say easy to see view. So you can see if there's a group of mobs making a windbreak or starting to plan or design a windbreak, and you could intervene early. You would message them or walk over there and attempt to resolve the issue. So the automated visibility helps. And it's not like if you and I are in a mob, we've got to update the Justice Board. It's largely automated, right? And which means it's not perfect. The automation is not 100% perfect, but it means there's great visibility that's pretty close to reality that doesn't take our time. So that helps, but people do step on each other's toes. So that's one of the reasons there's 2 different windbreaks here. And not like the windbreak team and we wait in the queue to make the next windbreak from the one windbreak team. It's because these groups just independently started making them. So they're different designs. And they're like, I want to put it here. And they're like, we already are. They're like, okay, well, we'll put it here. And the reality does happen. Yeah, it's not this planned up front, single one-piece continuous flow system. There are people stepping on each other's toes. It happens a little less because visibility is high.
Hey,
Thank
Joey.
you.
Hi, all. A question. Which tool are you using then? Are there internal tool?
Yeah, it's internal.
All of them.
Yeah, the reason, I mean, Tesla would rather use external tools. They would. They use very few, almost zero external tools. The reason why is all of the current crop of tools takes a significant amount of time just to use the tool. They want things that don't require any human intervention. I mean, there's developers, you know, because it's in-house, right? There's developers making those tools, but they want it to never take, if you're on the windbreak team, they don't want you to have to log in and update status and add your tickets. They don't want that. They want people doing the engineering on the windbreak. So they want a system that takes a guess and makes some reasonably useful conclusion. And every tool in Tesla is like that, and SpaceX. The idea is you don't have to click, you don't have to do anything. You can just see things. And there's no tool you can buy like that. They all require logins and content placing, so they just don't use them.
Thanks.
Great point, Claire. And also Antonio, thank you very much from before.
So, hi there, Matteo here.
Matteo?
What is the ratio of engineers focusing on internal tooling versus external products?
Okay, it's not fixed because people move around, right? Which is already kind of strange. But the question you asked, I think, is incredibly important. The mix changes, but my guess is it's about 50%. People focused on internal tooling, automation, basically. About 50% of total budget. Now, that's for a hardware company. That's for a company making rockets and cars, right? And the factories that produce them. If it were just a software company, for example, Musk just moved into Twitter, right? I assume the ratio of automation compared to everything else would be closer to 90%. The machine that makes the machine is the product. A great point, Matteo. Okay, we're at time. I really appreciate it. If there's any follow-up comments or questions, I'd love it if you just tweet at me. I'm at Joe Justice on Twitter. If it's sensitive, you can email. I'm Joe at abi-agile.com. ABI Agile Business Institute agile.com. You can email if it's truly privileged information, sensitive information. But in general, I prefer to be contacted on LinkedIn or Twitter. So that way you don't only get my opinion. Other people will hopefully join that conversation and say, actually, this is a better answer, right? So you're not limited by just me. But I'm happy to be contacted for comments or questions. And if you want to see what I'm up to, I do have a website, abi-agile.com. Super thank you, everybody. If I'm lucky, I'll meet some of you in Australia. We'll do an event like this in Australia, or we'll do the class online for ScalaPay or something. But I'm glad we had this session. Thanks.
Thanks so much, Joe. I think we're super privileged to have Joe present to us today. What Joe didn't mention was his background. Joe's built a racing car company that's in a very short amount of time. In also 3 months, I think you built the first company, a company called WikiSpeed. So there's a lot of other things to Joe that he hasn't spoken about. But I think the central theme here is speed, and just doing amazing work and just enjoying doing that work. I think we have a lot to learn from Joe and like the examples at Tesla, etc. So yeah, I mean, please do reach out to Joe if there's any questions. Feel free to. Joe's doing a workshop with us for another day, so feel free to Slack me or Ricardo if there's any other questions that you want us to pass on to him as well, or reach out to him direct. Thank you, Joe. And thanks everyone for your time.
Thank you. Have a nice day.
Thank you.
Thank you.
Joe.
Thank you.
Thank you.
Bye.
Thank you so much.
Bye.
Bye.
Thank you. Bye.
Bye.